So this is experiment number 7. This is Ohm's law. The objective of the experiment number 7 is to study the Ohm's law as applied to a linear DC circuit to show the behavior of some non-linear circuit elements which do not obey the Ohm's law. Actually, we need to find out the two results for the Ohm's law. The one is for the linear circuit and the other one is for the non-linear circuits. Obviously, we know that the equation for the Ohm's law is equal to V divided by R, and the circuit diagram for this experiment is given like this. This is the power supply. Similarly, we have the power supply on board, and this is a ampere meter, and similarly we have ampere meter in our this power supply, and similarly we have attached an extra ampere meter, so which is we can see values on both ampere meters. And here's the resistance. We will use resistance for a linear relation. Here is the hundreds ohm resistance that we will use for the linear relation that will obey the Ohm's law. And similarly, here is the voltmeter. We have voltmeter. Similarly, voltmeter on our variable power supply. A variable power supply, we can control the values of current and voltages about our limits. And similarly, we have attached an extra voltmeter. We can see the values of voltage on both sides, but here is a problem. There is a error of 0.5%. Mean if the value of the scaling of this voltmeter is 0 to 5 is 10 small scale. If we want to calculate the 1, it means we have to see the value at 1.5 or third line of this meter. So this meter is a 100% correct meter. So let's start with the circuit diagram or the systematic diagram of this experiments. And first of all, we will start from the negative sides of the power supply. Let's start from the negative side of power supply. 1. And negative side to resistance negative. So this is the negative of power supply and negative of the resistance R. And from resistance R negative to ampere meter negative. This is the terminal of ampere meter common, and we will put it into resistance positive side. After that, the positive of the ampere meter goes into power supply. So this is the positive terminal of the multimeter or ampere meters, and it will go to the positive side of the power supply. If we want to attach the other voltmeter, the voltmeter in systematic diagram in diagram is parallel to the resistance R. So positive of the resistance R goes into positive of voltmeter, and negative of the resistance R will go into negative of the voltmeter. So our systematic diagram is complete. Now we will we have a table like for a linear relation. So this is a table that we choose like 1, 2, 3, 4, 5, 6 and 7. We know that these are the both parameter of the Ohm's law, voltages and ampere I. And in these conditions, our systematic diagram will obey the Ohm's law. Let's operate with the systematic diagrams and increase the voltage to 1. So as we increase the voltage to 1, here is the 1 voltage, and we can see the value of current is 0.01. So we will write here the value of current 0.01, right? And now the value of voltages is 2, and similarly the value of current is 0.02. And next we will operate to 3 voltages, so the value of current will also 0.03 ampere. 1. So on, as per we will increase the value of voltages. At 4 the value of current will become 0.04, at 5 0.05, and at 6 0.06, and at 7 0.07. So the actual reason is, as we increasing the voltages, the current will gradually increase. Mean we can see the relation is a directly proportional relation. So this will 100% follow the condition ohmic, and the graph we will get will be straight line.
One.
Now for the non-ohmic condition, first for the ohmic condition we use a resistance. As we increase the value of voltages, the value of the resistance will remain same. But here for the non-ohmic condition we use a bulb. We use a bulb which will 100% and surely behave non-ohmically. Mean that as we will increase the value of voltages, the value of the resistance will not remain same. So let's calculate the values for non-ohmic condition. The only thing we have to change is the connections of resistance to put into the connections in the bulb side. So let's calculate the value of for the non-ohmic condition. So at 1 volt, let's say the value at 1 volt and the value of the current is
1.
Similarly, we will start from the voltage 1 and we will increase the value of voltages like 1 volt, and the value of the current is 0.50.
1.
Now the value of voltage become 2 volt. So let's increase the value of voltage from here. Now we can see the value of the current is 0.73. Similarly, we can see that the value of ampere is not increasing linearly. So however the value of voltage is increasing linearly, but the value of current is not increasing linearly. Now similarly, from volt at 3 volt the value of the current is 0.90, and at the 4 volt the value of the current is 0.96. The reason of this non-linearity or non-linear behavior of the Ohm's law is actually the resistance of the bulb is not same at all voltages. Or the other words I can say that the resistance of the bulb is not changing continually or in the same order when we increase the value of voltage. Now at the 5 volt the value of the current will become 1.04, and similarly we will increase the value of current at 6, at 7, at 8, at 9, at 10, and at all values we see that there is non-linear behavior of in the values of current. So this is the relation for non-linear values of current, and this is the non-linear ohmic behavior of the Ohm's law. Thank you.